Okay, so the title of this video should be "Do not buy this display unless you are making DIGIFIZ, the digital dashboard from the classic Volkswagen Golf." And since that's exactly what I will be doing today, I guess I can use this display. Now this is a touchscreen, so I can pretty much change everything on this dashboard. The RPM gauge, which also controls the speed, the coolant temperature gauge, all the warning lights, the warning light for fuel, and the multifunctional information display. By the way, the DIGIFIZ means the Digitales Fahrer Informationszentrum. The Fahrer means driver, and I think that you can translate the rest. But let's talk about why you should not buy this 7-inch Nextion intelligent display if you are making pretty much anything else other than the DIGIFIZ. And let me compare it with the 5-inch version of the Nextion intelligent display, and maybe now you can see the problem, maybe? Please let me know in the comment section if you see anything wrong, because I would really like to know if you see the problem or if it's just me. And while you think about what's wrong, let's talk about the sponsor of today's video, which is PCBWay. And that's because if you are making electronic projects, sooner or later you might need PCB or PCB assembly or even SMD stencils, and in all those cases PCBWay has you covered. They offer all of those services for a nice price. Actually, if you use the link down in the description, you can get 10 PCBs for free, only paying for shipping. They also offer a lot of other services like 3D printing, CNC machining, and injection molding. So thank you PCBWay for sponsoring this video, and let's get back to our project. The problem with this display is much more visible with a different project, for example this simple square image. And maybe now you can see the problem. If I measure those sides, this should be a square, but it's not, it's a rectangle. One side is about 7 cm, but the other side is only 6.5. And that's because this display has non-square pixels, which, I will be honest with you, this is driving me crazy. Thankfully the DIGIFIZ design has no squares and no circles, so even when the design is slightly stretched, it's a little bit wider than it should be, it still looks fine. And so today I will show you how to make this project using either the 5-inch or the 7-inch intelligent display from Nextion, and in the next video I will show you how to connect it to Arduino and to a real car to show some real values, but today it's all about the DIGIFIZ. Now the DIGIFIZ was the optional add-on for some VW vehicles like the Volkswagen Golf around the year of 1985. Surprisingly, not many people have opted for such option, so nowadays it's quite rare and quite expensive. And I really like how this looks like. I think it looks great even after almost 40 years. So let's recreate this DIGIFIZ dashboard design, and I will cheat a little bit because I have already prepared a Photoshop file, which I will open in a free online graphic tool called Photopea. So my Photopea file looks like this, and I have this group which has all the layers for those individual elements, and currently everything is in the on state, so everything is shining and everything is being enabled. In order to use it with the Nextion display, we need a second state where everything will be not shining or everything will be disabled. So I will create it by right-clicking and selecting duplicate layer, and this one will be for the off state, and let's just hide this one and open this group, and I want to hide everything that should not be shining, so for example those both gauges, the segments red and segments for the coolant temperature shouldn't be visible, and I will do the same thing for the RPM gauge, so RPM segments red and the RPM segments in the yellow color, they shouldn't be visible. Same goes for all those digits, so the speed digits should not be visible, and all the digits on the bottom should not be visible, which means that the odometer digits should not be visible, the time digits, the multifunctional display digits, as well as the fuel digits, and these are simple for the low fuel. As for the warning lights, I will hide all the icons, and then for the background layers, I've already prepared this one, so if I just hide the on layer, this one is just a slightly faded version of the on layer, so they are not that visible. The only thing left to change are those icons for the multifunctional display, and I want to recolor them to have the background color same as the background for the digits. And I will select the background layer, and then I want to change the color, and I can do that in a few different ways. For example, going to Edit, Fill, and then selecting Fill with the custom color, click this swatch and select this color for the background color for the digits. Click the OK button, and then make sure that this checkbox is being checked, otherwise it will fill everything, and click the OK button. And then select the icon and do the same thing, but this time I will select the black color as the fill color. Again, click the OK button, and this is the disabled version of the icon. So I will repeat the same process for all the other icons. And I think that's all that we need for the off state, for the disabled state of the graphics. which means that we can now export those two images, those two groups, and we can do it in a few different ways. For example, by going to File, Export as the PNG file format, Or I can as well rename those layers to include the -e- in the beginning of the name, and I will do it for both of those. And if I do so, I can then go to File, Export Layers, and if I have this checkbox being checked, that will export me all the layers which starts with the -e- in the name. Set the format to the PNG file format and then click the Export Layers button. And that will export the zip file which has those two images inside, the off state and the on state. So I think it's time to jump to the Nextion tool and try to show those images on the Nextion display. You can download the tool from the Nextion website by going to Download and selecting the Nextion editor, and then either downloading the executable or the zip file. The installation is straightforward, just keep clicking on the next buttons. And once the software is installed, it looks like this. Now the first thing to do in here is to create a new project by going to File, New, and give it some meaningful name. And once you click the Save button, we want to set the display that we have, and there are 4 different types, being the Basic, Discovery, Enhanced and the Intelligent. And as mentioned in the beginning of the video, I will be doing this project for the 5-inch and the 7-inch display, and I guess I will start with the 5-inch version. By the way, both of those displays have the same resolution, so the switching between those two should be very simple. Then I will go to the Display tab and select the orientation, which in my case will be this one, the horizontal orientation, and click the OK button. And we have a blank canvas on which I want to show our image. So I will click on the Pictures tab and click on the plus icon to add our 2 images to the project. Again, one for the off state and one for the on state. And let's show one of those images on the canvas, for example using the Picture tool, so click the Picture tool, and in the Attribute panel I will click the Pick drop-down menu and select the Browse item, and select for example the fully lit image, click the OK button, and now our design is there. Now before doing anything else, I want to see how this image looks like on the display, so let's try to upload it to the display, and we have 2 different ways how to do that. The first one is using micro SD card, which is what I will start with, and for that we need to first export the TFT file by going to File, TFT File Output, and in here I will click the Output button, and that will generate the file and open the folder. Then I will insert the micro SD card and copy this file to the micro SD card. After that, I can remove the micro SD card from my PC and insert this micro SD card into the Nextion display. Now as for powering the display, we need 5 volts, and with every Nextion display you will also get this little board that will get the 5 volt from the USB power supply and expose those on those 2 male header pins. You will also get this cable, so I will connect the red wire to the plus and the black wire to the minus. This small little board to the USB cable, and this connector to the Nextion display. And as soon as I do so, the display will show the message that it will update the data from the micro SD card, and then it will do that, and just because our sketch is very small, it will only take a few seconds. And so once this new data is uploaded, we need to disconnect the display from the power, then remove the micro SD card, and then connect the display to the power again. And now we should see our full screen image with all the segments being lit. Which is a great first step because we know that everything works, we just need to make those elements dynamic. So let's jump back into the Nextion editor and talk about why we only need 2 images for our project. And to make things more understandable, I will actually delete this image, this picture from our design, so there is nothing else in there. And so not only we can display image, but we can also display a portion of the image, and for that we will use this crop tool. And again, I will select the pick to be one of our images, for example this one. And if I make it slightly bigger, you can see that we can see the Volkswagen logo, but if I move this around, now I can see those speed digits or any part of the image. So the position and the size of this component sets which part of the image we want to display. So let me actually delete this one as well. And instead, I will insert this dual state button. For that, I will set the style to be not the solid color or the image, but to be the crop image instead. And for the pick number 1, I will select the off state, and for the pick number 2, I will select the on state. Then I will try to move the button over one of those warning icons, and it might be hard to see, but if I change the value from 0 to 1, I will now see the warning icon being lit. And of course I can move the button to a different position for a different icon to be displayed. And I can try to run it in the emulator by clicking this debug button, But if I do so, I see the error message down here saying that we have the invalid font ID, and that's because our button is supposed to be showing some label, this text, using this font, but if I jump into the fonts tab, we don't have any fonts in our design. And while we will add fonts later, for now I think that I can fix this by not showing any label, so setting the text to be the empty string instead. And then click the debug button again, which will run our project inside the emulator, and I can click this button to toggle between the on state and the off state. And I think that it shouldn't be hard to copy this button 12 times to support all the warning icons, so let's actually try that. I will set the button position back on the first warning icon, which is this one, and then I will copy and paste this button 12 times. And then select all the buttons and align them all to top and make the horizontal spacing equal. And if I run the simulation again by clicking the debug button, I should be able to toggle all those individual warning lights one by one. And I guess for now I will set the value to be 0 for all of those, maybe except for the first one, which is for lights. And I think that it might be a good idea to try it on the real display, but this time not using the micro SD card, but uploading it directly to the display. And for that you will need this little board, which is the USB to TTL converter, the USB to UART converter, which will allow to upload the design from the PC to the Nextion display. This board is from Nextion, which makes the connection quite simple. You just connect this cable to the board and the other side of the cable to the display. And then of course connect the board to your PC using the USB cable. And we should see our static image on the display. So let's jump back into the Nextion editor. And uploading the design to the display is quite simple. You just click the upload button. Now you can keep the COM port to auto search, but most likely the Nextion display will be connected to the last port, in my case that's the COM number 19. I will keep the baud rate to the highest value and then click the go button. And you can see that it took almost no time, because the images were already there on the display, so it just skipped those images during the uploading process. So close this dialog. And we should see all those warning icons on the display, and we can click on those to toggle them between the on and off state. And that was quite simple, right? So let's continue also with the other elements. And one of the most important parts of the design is this big RPM gauge. And we have the progress bar component, which seems like a great fit because the RPM gauge also looks like the progress bar, filling from the left side all the way to the right side. But if I open the style drop-down menu, I can only switch between the solid color and the image. And if I select image and then of course select the first image and the second image, you will see that it's taking the whole background image. So even when I can change and animate the transition between those two images, it's just changing everything on the whole screen, which is not something that I want. Which means that I will delete this component and instead try to use a different one, for example this one, which is called the slider. And the slider also works in a similar way as the progress bar, meaning that I'm switching between the left side and the right side, and in here I can set the style to be the crop image, and of course select the off state for the first one and the on state for the second one. And if I run the simulation, clicking the debug button, I can drag this slider to animate between the on image and the off image, so that's working just nice. But what's not so nice is this big circle in the middle. And if I open the properties again, I can change this to be the rectangle, which is actually not helping much, or I can change this to be the image instead. And since we haven't set the image, which is this one, the pick 2, you can see that nothing is being displayed and it looks almost perfect. But if I change the value to be only 0, it doesn't go all the way to the left side, because you can imagine the circle in here, like so, and this is most likely the center of the circle, which is the divider between the off image and the on image. But I think that we can fix it by setting the image to the handle, which will be much smaller. So back in Photopea, I will create a new image and only make it 10 by 10 pixels with the transparent background. And this is pretty much all that we need. So no content, being 10 by 10 pixels. And then I will save it as a PNG image by going to File, Save as the PNG image, give it some meaningful name, for example, transparent handle 10 by 10 pixels, and save it as a PNG image. Then I will jump back into the Nextion editor and edit this image by clicking this plus icon and selecting our image. And then select the slider component and set the pick 2, which is for the handle, to be our image, which is this one, the image with the ID number 2. And you can see that immediately the gauge jumped to the minimum value, and if I set the value to be 100, so 100%, it will jump all the way to the right side. So I just need to reposition this a little bit and make it slightly bigger to cover the area of the gauge. And since this is the slider and not just the progress bar, I can open the simulation by clicking the debug button, and I can actually set the value using my mouse. Now you can see that I'm also changing this area because this is a part of the image for the slider, but I will not worry about it right now because later on it will be covered with the actual digits. So instead of fixing this, let's also create the second gauge, which is for the coolant temperature, the one on the right side. And I will use the very same technique as I was using for the RPM gauge. I will add one more slider component, but this time I will make it in a way that it resembles the vertical orientation, and change the mode to be vertical instead of horizontal, and change the style to be crop image, and the handle to be image as well. The unselected image will be our off image, the selected image will be our on image, and finally the handle image will be the transparent image, the image number 2. And again, I need to reposition this a little bit to only cover the area of the actual gauge. And once this is done, I can again open the simulation and change the value of the gauge using my mouse. Now before we try that on the real display, I would like to do two things. First of all, I would like to set the background of our page to be the disabled image, and I can easily do that by selecting the page either from here or from this drop-down menu, and then change the style to be image and set the picture to be the disabled image. And that actually makes quite a lot of difference. And the second thing is that I've said that those digits are not bothering me, but they are actually bothering me a little bit, so I'll temporarily fix it by adding a crop image and then positioning over this area, like so, and set the image to be the disabled image, which is this one, so it will cover this slider. And if I debug this again, I should be able to change the value of the gauge, actually both gauges, while this area is empty for now, and of course I can still set all those individual warning icons. So let's close the simulation and try to upload it to the display. And that should still be as simple as clicking the upload button. Again, the communication port will be the last one in most cases, and make sure that the speed is being set to the fastest one, and click the go button. Now, since we added a new image, it will upload all the images, but you can see it still only takes about 14 seconds. Actually, only 11 seconds. And we should see the very same design on our display. And again, I can use my finger to set the value for the RPM gauge by dragging it to the left or right side. I can also change the value of the coolant temperature gauge, and same as the last time, I can also toggle all those individual warning lights. So the big thing that we are missing at this point are all those individual readouts like the speed and the time and multifunctional display, which are drawn using some 7-segment digits. And you can find a lot of different 7-segment digit fonts that you can download for free, but I wasn't able to find the one that looks like the original DIGIFIZ design. So instead I created one, and it is actually there in the Photopea file all the time, because those digits for speed, those are not made using any font. But if I select the layer, you can see that those digits are made from individual shapes, so I can just hide and show some shapes to show any digit. And this is actually not the first time when I was creating 7-segment digits. I have a video where I was recreating the designs from the YouTuber named Posey. I will put the link down in the description, and it has some information about how to create your own 7-segment font. For now, let's assume that I already have the design, which is the case. Again, those 7 shapes for 7 segments, and I will create a new file in Photopea and set it to be the size of 248 by 248 pixels. And hit the create button. And then copy those shapes into that file by just dragging this folder into this new file. And I might just double click and change the color so I can see them better, but the color doesn't matter for the actual font. What matters is the size, and I need to make this much bigger by going to Edit, Transform and Scale, and just make it again much bigger to just almost fill the entire space of this file, for example like this. And then I need to export this in the vector format as the SVG file by going to File, Export as the SVG file, again give it some meaningful name, and click the Save button. That will export the SVG file. And then I need to use that file to create the actual font file, you know, the one that you can use in Windows, being the OTF file, the Open Type font. And for that task, I have found this free online tool, which is called the Glypher Studio. So I'll open this website and give it some meaningful name to my font, for example the DIGIFIZ segments, and click the Create a new font from scratch. And since I want to start with digits, I will click this 0 digit to create a new glyph for the 0 digit, and click this button to select our exported SVG file. That will import all those 7 segments, and of course for the digit number 0 we don't want to have this middle segment in there. But before I delete it, I will just copy everything into the clipboard by clicking this button, and then click this button and go to digit number 1 and paste it using this button, and do the very same thing for all the other digits. So now all those 10 digits have those 7 segments, and I can start deleting some of those segments. So this will be for digit number 0, for digit number 1, I only need those 2 segments, and so on and so on. And after a little bit of deleting, we should have all those 10 digits ready, which means that I can click this button and go to live preview, and in here start typing our digits. So digit number 1, digit number 2, and you can see that something is wrong because those digits are being drawn on the same space. And that's because if I go back into the overview and select any of those digits, the width of the glyph is set to 0, so I need to adjust it and make it wider, maybe going all the way to about 1500 or so. And that should fix it for the digit number 0, so if I go into the live preview, 0 and 1 should be fine. And if I don't want to set the width for all those individual digits, I can actually go to the global actions, and if I scroll down, there is a way how to set the width for all those individual glyphs, which is in here, so I will enter our value and click the convert project to mana space, which will pretty much set the width for all those individual glyphs for those individual digits. Which means that if I now go into the live preview, I can start typing the other digits and everything should be working as expected. Now I've told you that we only need 10 different digits, but I will actually add 2 more glyphs. I will jump back into the overview and add the space character, the white space character, and all that's needed in here is to set the same size, same width as all the other characters. And then I will add 1 more character, and it doesn't quite matter which it is, for example the exclamation mark. In here I will paste the 7 segments, and this glyph will be the fully lit first digit, because as you can see in here, in the original design the first digit is missing 1 segment. And I think that's because you can only go up to 399 kilometers per hour, not all the way to 400, which is kind of reasonable. Although it's kind of questionable how much savings you can get from not including 1 segment, but in any case, it will be here in our font. And if I jump back into the live preview, I can insert the space character and I can include the exclamation mark. Now if I show the bounding box and maybe make it much bigger, you can see that the content is not quite matching the bounding box. So I might go as well into the settings and open the font properties. And usually in a font there is something called the baseline, so some characters are above and some characters are below the baseline, but in our case everything is pretty much on the same place, without any real baseline, so I'll just set the descent to be 0 and the ascent to be all the way to 248, which is the size of the individual glyph. And then set the capital letter height as well as the X height to be the same value. And if I go back into the live preview, you can see that the bounding box is matching the glyph area much better. Which means that we can export the file in the OTF file format by going to File, Export the OTF file, and that will export the OTF font file. However, we cannot use this font file directly in the Nextion editor. We need to first convert it into the font file that the Nextion editor will understand. For that, I will first install the font. Then I need to close and open the Nextion editor again. And in here, select Tools Font Generator, and of course the font will be our DIGIFIZ font. As for the size, I will select the custom one, and I've measured this to be 120 points. And we don't need all characters, we only need our digits, going from 0 all the way to 9, the space character and the exclamation mark. Then give it some meaningful name and click the Generate Font button. And save it somewhere. The Nextion editor will show you the file size and asks you if you want to add this file into your project, which is something that we want, so click the Yes button. It will add this font into our project, and now we can use this font for our labels. Now if I double click this font, it will show me the font preview, and this is nothing else than just a bunch of images, so we have the image for each individual glyph, and that's the reason why we had to choose the font size when we were generating the font. So let's use that font in our design. I will delete the crop image component, and instead I will add a new number component, and of course make it about the size of the speed readout, like so. I will set the X alignment to be on the right side, and for the background I will set this to be the crop image, and of course the image will be our disabled image, which is this one, and I need to also change the color of the label. And if I jump back into Photopea, I can get this color and then remember those 3 values for the RGB. And then back into Nextion editor, I will select the custom color and enter those values in here, like so, and I can try to change the value to see how it looks like for different speeds. Now it would be nice to change the label and show different digits, and for now what I can do is when I change the value of the RPM gauge, I will also be changing the speed. And that's a simple thing to do, but before I do so, I will rename those components and give them some meaningful names. So instead of calling this H1, I will call this gauge RPM, and instead of calling this label N0, I will call this label speed. And for the RPM gauge, I'll actually go from 0 all the way to 7000 to mimic the range. And then down here in the event section, I want to change the value of the speed when I'm moving over the RPM gauge. So I will say that the label speed value equals the gauge RPM value, but the RPM gauge value goes between 0 and 7000. And maybe I only want to show the speed up to 250. So I will divide it by 28. So divide it 28 and then try to run the simulation. And as I'm dragging the mouse over the RPM gauge, I should be also changing the speed going from 0 all the way to 250. So let's see how this looks like on the real display. Again, click the upload button and then click the go button. And same as in the simulation, I can change the speed value by changing the RPM gauge value. Also, everything else should be still working, meaning the warning lights and the coolant temperature gauge, which means that we can continue with all the readouts on the bottom of the screen. And I've used the very same technique as for the speed digits, meaning that I've located the 7 segments for any of those bottom digits, for example this one, so those 7 segments. And I've copied them in a new file in the size of one glyph inside our font, which is 248 pixels. Exported that file in the SVG file format and then imported into the Glypher Studio application, actually website. The difference from the last time is that now we need few more characters. For the clock display we need a separator, either being the colon or empty character. Then we need the R symbol for the low fuel warning. And then I believe that we also need a decimal point for some of those readings for the multifunctional display. And it looks like that we also need a minus sign for the negative temperature. I've included all those special characters in the font. If I switch to the live preview and maybe make it much bigger, I've included the colon character for the time, but I've also included the semicolon character, which is just the empty character, but it's sharing the very same size as the colon character, so I can switch between the colon and the semicolon to toggle between the divider for the time, while still keeping the same size of this character, so it will not be jumping around. And I can still use the space character, the empty character, to have the same size as those individual digits. I've also found this image. Apparently some of the messages could be displayed, at least this one, the INSP for inspection. So I've decided to edit the alphabet as well. And while you cannot create all the characters using just 7 segments, we can at least type in the INSP for inspection. So I think it's time to export the font in the OTF file format by selecting the file, export the OTF file. And then install the font in Windows. Then restart the Nextion editor and select Tools Font Generator, and for the font select our DIGIFIZ font, and I think that this time I've measured the size to be 50 points, and I guess I can go with all the characters, although it will most likely include some of those which are missing in the font, but it doesn't quite matter that much. So just set some meaningful name and click the Generate Font button. And save it as a Nextion font file. It will show the size and asks you if you want to edit this font, which is something that we of course want to do. Then close this dialog, and if I double click this font, you can see that we have all our characters plus a few characters which were not inside our font, so they were most likely used from some default font, but it doesn't quite matter that much. So just close this dialog, and for the readouts I will select a new text component, so just click the text component to edit the text component into the design, and maybe start with the clocks, which should be around here. As for the font, I will select our first font because that's the ID for the smaller font, and for the actual text let's go with 12:34. For the background color I will select this to be the crop image, and of course the image will be our disabled background image. I want everything to be right aligned on the x-axis and maybe move it around to align properly with the background image. And of course the color should be our last yellow color, which might be this one, I guess it is. Let's rename the object name to be the label time, and then add one more text, and that will be for the multifunctional display. Let's for example show the average consumption. So again the font will be the font number ID 1, and the content, the text will be space 9.6 and space. And of course again the background will be the crop image of our disabled image. The color will be our yellow color, and I guess we can keep the alignment to be the center because we can always add those extra space characters around to make it center aligned. So just move it around a little bit until you feel it's being centered properly, and then rename it to be the label multifunctional display. I guess they call it MFA in the original version, so I'll use the very same name, so label MFA instead. Then copy and paste it one more time, and this will be for fuel, so we only need 2 digits, for example 20 for the number of liters for the fuel, and let's rename it to be the label fuel. And this time I want the X alignment to be on the right side, and then copy and paste it one more time, and this will only show the R symbol for the low fuel warning, but I have a special character reserved for this, and that's the exclamation mark for the R for the reserve. Let's name it label reserve, and we also need to change the color to match the R color in the original photop file, which is quite simple. It's just R being set to 254. So inside the Nextion editor, I will set the color to be the red one, and then I might use the arrows on the keyboard to align everything properly. Now if those labels, those names of those objects are getting in your way, you can click this button, the ID button, and that will hide the object names. And then of course you can click it again to show those object names if you want to. For the odometer, I need slightly smaller font, which I've already created. So inside the fonts tab, I will just add this font, which I already have for the odometer. And then add a new number component. And for the font ID, we want to use this font ID number 2 for the smallest font. The background should be the crop image, being our disabled image, and the color should be our yellow color. And let's just test this with the value of being 1, 2, 3, 5, 4, 6 for showing 6 different digits and align everything properly. I will set the X alignment to be the right side, because if I only want to show few digits, it should be aligned on the right side. And as for the object name, let's actually show the object name. Let's rename this one to be the label odometer. And if I click the debug button, I should see all those individual labels being shown on the screen. So let's also quickly test this on the real display by clicking the upload button and then clicking the go button. And once this is uploaded, we should also see those labels on the Nextion display. And while the top of the screen is responding to our touch events, there is nothing happening if I press the labels. So as the last step, I will add a simple logic that will change the labels when I press them. And maybe start with the R symbol, and when I click it, I want to toggle between showing and not showing the R symbol. And there is something that I haven't told you yet, and it's quite important. If you look into properties, some of those properties are black and some of them are green. And there is a reason for that, and that's because the black ones are the ones which cannot be changed during the runtime, and the green ones are the ones that could be changed. So for example, we can change the position, but we cannot change the size. We can change the text, but we cannot change the object name. So down in the event section, I will click the touch release event. When you release the mouse or release your finger over this object, and I want to say that if the content, so if the label underscore reserve.txt, so if the text equals the exclamation mark, which is our R symbol, in that case I want to set the label reserve.txt to be empty, so equals the empty string. And if it's not the case, I want to change it back into the exclamation mark, being the R symbol. And if I press the debug button, you will see some kind of error, because the code is quite restrictive of how you can write it. And it sounds like that you cannot have this bracket on the same line as the if statement, so I have to move it to the next line instead. And hopefully now it will work. And of course there should be 2 equal signs, yeah, that's my mistake. So click the debug button again. And now when I press the R symbol, I should be toggling between showing and not showing this symbol. So this seems to be working just fine. Let's move on to the next label. And maybe for the odometer, let's just increase it all the time, and for that I will add a new timer component, and I will lower the time, the interval, all the way down to 50, which is the minimum value, so 50 milliseconds. And inside the timer event, I will set that the label odometer.value equals the value plus 1. And if I run the simulation again, I should see the value increasing all the time, which means that I can move on to the multifunctional display. And for that one, I want to click on this whole area and switch between all those different readouts. And I will start by adding a few more dual state buttons for those individual icons around this label. And maybe zoom in a little bit so I can see it better and position it in a better way. And of course change the style to be the crop image with our disabled and our enabled image. And maybe change the value to be 1 so I can position it easily. And then use the arrow keys on the keyboard to set the right position. And set the correct size, like so, and give it some meaningful name. So this will be button average consumption. And I believe there is a limit of how long the name could be. So if I type in consumption, I guess I will see the warning message, because the name can only be up to 14 characters long. So that's something to keep in mind. But I will continue with the same approach. So copy and paste this button, make it slightly smaller. This will be button average speed, and so on and so on. Let's quickly run the simulation if the sizes are correct. and it seemed to be the case, so everything seems to be working, but instead of clicking on those individual elements, I want to click on this whole area to switch between those different readouts. And for that I will add one more button, but this time the button will be invisible, and for that I will use this hotspot area, this hotspot component, and move it over this whole area. And make it, of course, big enough to cover everything, and I will rename it to be the hotspot MFA, the multifunctional display. And since I want to keep track of which section is selected, I will create a one more helper variable, and for that I will click this variable button and rename this variable to be the MFA function. And then click back on this hotspot MFA, and in here I will simply find out which MFA section is being selected. So I will say that if the MFA function dot value equals 0, in that case I want to show the driving time, so the button drive time dot value will be 1 and all the other buttons will be 0. And let me actually make this slightly bigger so we can see the code nicely. So the button distance value will be 0, button average consumption will be also 0, button average speed will be 0, and let's not forget about putting the value in here, otherwise it will not be working. Button oil temperature will be 0 and button ambient temperature value will be also 0, and I'm missing one more value in here. And finally I will set the value of our label, so label mfa.text. And for the driving time, I will, for example, go with 2:35. And of course, when I click the hotspot, I want to switch to the new function, to the new section. So let's say that the MFA function value is the MFA function value plus 1. And if the MFA function value is bigger than 6, in that case, I will jump back to 0. So let's try to run the simulation again. And if I click it, it will jump to 1, so nothing is happening, 2, 3, 4, 5, and at some point it will jump back to 0, which is this point. And now we have switched to the driving time and updated the display. Which means that all that's left to do is to have more if statements. And if you are not sure how those if statements should look like, you can go to help and select the instruction set. And that will open the instructions, and I will search for the else statement, and it looks like that the else should be together with the bracket, so else I will use this example and paste it in here. So else if the MFA function equals to 1, in that case I want to show the distance driven and update all those values accordingly. By the way, I'm using the semicolon as a separator because it has the same size as the colon, but it's empty, so it's not changing the size of the label. And if I run it again, now the MFA function value is 0, and clicking this area will change it to 1, which is the distance driven. So let's just continue like this with all the other sections. Now I haven't realized that the value only goes between 0 and 5, so I need to change the code up here to only go between 0 and 5. And I will temporarily move the hotspot out of the way because I want to set all those buttons to be in the off state, so set the value to be 0 except for the first one, and then change the label to be matching what we will be setting for the value of 0, which is this 2:35. So set the label to this value, so the text should be this one, and then move the hotspot back over this area and click the debug button again, and I should be able to click on this area to jump between different sections. So let's also try that on the display. Again, click the upload button and then click the go button. And it will only take a few seconds because it's skipping the resources. And on the real Nextion display, we should be also able to click on this multifunctional display to switch between different areas. So I guess at this point, let's do one more thing, and that's for the time display. And the Nextion Intelligent Display comes with the RTC, the real-time clock module, which means that we should be able to show the real time. So let's jump back into the Nextion editor. Actually, let's jump back into the Nextion documentation. And in here, I will search for RTC for the real-time clock. And if I scroll down a little bit, it looks like that we have access to 7 different variables that will report the year, the month, the hour, minute, and so on. And I know that the clocks should be showing hours and minutes, but just to update the display a little bit faster, I will show the minutes and seconds instead. So back inside Nextion project, I will add a new variable and call this time minutes and change the variable to be the string. And then I will add one more variable, and this one will be time seconds, and the type will be also string. And we will reuse our timer, and what I want to do is to convert minutes, which are stored in the variable called RTC4. So minutes to string, and then I will convert seconds, which are stored in the variable called RTC5. So convert seconds to string as well. And for the actual conversion, let's open the documentation again, because there is a function called convertX, and that will convert the number to text or vice versa. And down there should be some examples, and I think that this one is the one that we can use, because it's converting some number value into the text value with a specified number of digits. So I will copy this example and paste it in our code, and we want to convert the RTC4, so we want to convert the RTC4 into our new variable, which is being called timeMinutes.txt, and we want to use 2 digits. And then I will do the same thing, but this time I will convert RTC5, and I will store the value in the timeSeconds.txt again with 2 digits. And finally, I want to show the time, so I will set the label time.txt to be the timeMinutes.txt plus the divider plus the timeSeconds.txt. So let's try to run the simulation to see what happens. And indeed, we see the time as minutes and seconds, counting up each second, and since this is matching the time on my PC, it seems to be working just fine. So let's try to run this design on the real display, again by clicking the upload button and clicking the go button. And we do see some time, but it's different, and that's because we have never set the time on the Nextion display, so it kind of makes sense that it doesn't know which time it is. Thankfully, there is a simple way how to set the correct time on the Nextion display, and that's by going back into the Nextion editor, then opening the simulator, and in this operation drop-down menu, there is a function to set the RTC, the real-time clock, on the Nextion device. But in order to do that, we need to first connect the display to the simulator by clicking this drop-down menu and selecting Nextion device, then selecting the correct port and clicking the connect button. And then down here there should be a message saying connected, so we are now connected to the Nextion display, which means that now I can go to the operation and set the Nextion device RTC calibration. And as soon as I do that, the time on the display should be matching the time on my PC. Now, if you want to keep the correct time even after you unplug it from the power supply, you need to make sure that the coin cell battery is there, which seems to be missing on my display, which means that if I unplug it from the power and then power it up again, it will most likely show some random values. But let me actually unplug it again and show you how to run the very same design on this 7-inch display. And even when both displays use the same resolution, I cannot just press the upload button and click the go button, because you will see the message saying that we have a different type selected. Our current design is made for 5-inch display, while the display that we have connected is the 7-inch one. So what I have to do is go to device, and in here I have to select the correct device, which is this one, the 7-inch display. And then I should be able to click the upload button and click the go button. Looks like it's doing some more stuff. But after a few seconds, it's successfully uploaded. So now we have the very same design also running on the 7-inch display. And of course, everything that was working previously should be still working. So the RPM gauge, the coolant temperature gauge, all those warning icons, switching in the multifunctional display, and clicking the R label. Now before I end this video, I want to tell you about a few more things. If you want to know more about the Nextion displays, I already have 3 videos covering Nextion displays. I will put the links down in the description. If you are looking for something similar like the Nextion displays but with higher brightness and maybe nicer colors, I have this video with this project where I was using the intelligent display from the DIGIFIZ company. And if you want to perhaps use this display together with the SimHub application, I have a video covering that for the custom gear indicator. Finally, all the source files for this project are on the GitHub, the link is in the description. If you have any questions or comments, please put those down in the comment section. Thank you very much for watching, and I hope to see you soon. Thanks and bye.